quickly. Everybody stand up. Stand up. Out of your chairs. Stand up. Stand up. All right. So important thing to do with these types of events is to connect and meet other people. So I want everybody to meet one other person that they are not with. Introduce your name, where you're from, who you're with, and what you're trying to get out of this event. Just do it amongst yourselves. And again, what you're trying to get out of the event, where you're from. All right, now life story, 20 seconds. Okay, 5, 4, 3, 2, stay standing, 2, 1. Stay standing. All right, so stay standing up. So we're going to do a little quick survey. All right, so anyone who is not currently using VR in some way, sit down if you're not using it yet. All right. Anyone who's been using it less than 1 year, sit down. Using what? Using VR for less than 1 year, sit down. Using it less than 2 years, sit down. Less than 5 years, sit down. Less than 10 years, sit down. Less than 15 years, sit down. 20 years, sit down. 25 years, sit down. Okay, so that was not a. All right, that's not what that was for. That was not what that was for. So the title of my talk is "One Size Doesn't Fit All: Aligning VR Environments to Workflows." Unfortunately, in the little sheet there, it says "Aligning VR Environments," and I'm hoping people aren't thinking that's like trying to align the physical world with the virtual world. That's not what this talk is about. So this talk is about choosing the right type of VR environment for your workflow, for your needs. I'm not here to try to tell you what that is. I'm here to try to give you some questions to ask yourselves when you are looking at VR and augmented reality display systems and technologies, and the things to consider when you're trying to implement a solution. So we kind of did this by show of hands. We did this by standing up. So my second question, though, is, by show of hands, people who are using VR, who are using some type of wearable or head-mounted type of display system, raise your hands. All right, who is using something that is a projection-based or a flat panel-based VR? 1, 2. Okay, so much fewer. And that's part of the reason of the genesis of this talk. This talk actually came about. NVIDIA asked my company to create a talk for their GPU technology conference this year. And it was around the focus that the buzzword VR is back out in the mainstream. It's back out there. And everybody has a notion of VR, but the notion is that it's only these head-mounted displays. All right, and NVIDIA wanted to kind of help the industry recognize that there's a wide range of VR display solutions and technologies. I'm going to talk a little bit about that today. All right, so I'm with Mechdyne Corporation. Mechdyne's been around since 1996. Okay, so we've been doing this 20 years. Oops, too fast. We've been doing integration, we do software development, we do services. So Mechdyne is not a manufacturer. We don't produce a head mount, we don't produce a projector, we don't produce a cluster, but we integrate these solutions into a complete working turnkey environment for our clients. I am not here to pitch you on Mechdyne, okay? I'm Matt Szymanski. That's me in 1994 in front of a VR display system. Okay? So again, this is not a sales pitch. This is also a discussion. Don't save your questions to the end. If you see something that's a question, raise your hand. Let's talk about it. I operate much better in a discussion format. I don't like to lecture. That's not who I am. That's not what I'm about. So please, you see something interesting, pop your hand up. Let's talk. All right, so obviously lots of excitement around VR, head-mounted displays, right? And these are some of the ones you're familiar with. These are some of the ones you're probably not so familiar with, except for some of the folks in the back of the room who've been involved in this technology for a long time. You know, these types of systems have been around for a long time. So these are wearables. These are what we've been calling spatially immersive displays, as in a large room, a large environment. These are also virtual reality. All right, this is a picture of a six-sided cave. This is something we call a cave 2 that's made out of LCD panels. But the real question is, why are these conferences now popping up? Why are all these people using this technology in a variety of new ways? Well, cost, right? These systems have become accessible at the consumer level, at price points that small researchers with small funds, small dollar amounts can obtain these technologies and apply it to their workflows, apply it to their research. Companies can apply it to their industry problems. Okay, one of the things I want to talk about, and from an academic sense, is what are the requirements for something to be VR? People have been throwing around the phrase all day today, VR, 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 virtual reality. What is it? All right, so there's three main components that I think are the basic fundamental requirements to be considered virtual reality. One of which is 3D stereo. So stereoscopic vision, we have two eyes, we see two different images, we fuse them together. The system has to present to you stereoscopic images. Correct viewer perspective. We've been talking about tracking, right? A lot of people, trackers this, tracker that, lighthouse, tracking systems. Tracking systems generate information so that the software knows where your eye points are in the virtual environment so that it can draw it with the correct perspective. We see the real world from our eyes with a correct perspective. Most of us understand perspective renderings, perspective drawings, things in the distance, vanishing points, okay? And so the third one is immersive field of view, all right? And I'll get into each of these in a little bit more detail in a second here. So 3D stereo, tracking, which generates correct viewer perspective, and a wide field of view so that you can see as much of the environment as possible. With a narrow field of view, your brain picks up that there's something else out there, usually just emptiness, blackness if it's an HMD, outside environment, and it doesn't allow your brain to be tricked into the suspension of disbelief or the feeling of immersion. 3D stereo, okay, do a little exercise tester. So if everybody holds up one finger in front of their face, and then close your left eye, and then close your right eye, but open your left eye. Okay, so alternate, don't close both eyes. And then kind of go back and forth, all right? 1 second left eye and 1 second right eye. What you should be noticing right now is that your brain is actually seeing two different images of the world, right? When you hold up left eye, hold up the right eye, your brain is seeing two different images of the world because of where your eyes are placed. Your brain fuses those together into a single stereoscopic image. Most of us do not see double vision unless we're up drinking late last night. Maybe some of you were, okay? So the software, the hardware, the VR technology has to provide that stereo source to us. That can be done in a variety of ways. So with head-mounted displays, it's two physical different displays that are actually physically separated between the left eye and the right eye. And these projection type systems, it's usually by an alternating left eye and right eye image where you wear a pair of glasses that will filter out one image or the other. All right, and so when you go to the 3D movies, you look up on the screen without your glasses, you'll actually see a double image. That's because there's two images being projected on the screen at the same time. Polarized light filters are in front of the projectors and in front of your eyes, and one filter lets one set of light in, and one filter lets the other set of light in. Everybody pretty clear on polarized filters? Other options are flicker glasses that shutter back and forth. Viewer perspective, we're going to do another test again. Hold up two fingers, one in front of the other. All right, close one eye. Now keeping your fingers still, move your head side to side. What you'll notice is that your closest finger moves more relative to the background and your further finger moves less relative to the background. That's called parallax. It's objects in the distance move less relative to the background than closer objects. And that is one of the cues that helps give us depth perception. This is why people who don't have stereopsis or don't see in stereo or only have a single eye can still drive their cars. All right, they still have depth perception because of motion parallax, which is based upon perspective. All right, Our depth perception from stereo is only good to about 6 meters, 20 feet or so. After that, perspective gives us the greatest sense of depth within the environment around us. Okay? This is why flight simulators are all done in mono. If you have an object closer to you than 20 feet in a flight simulator, your problem is much larger than whether or not it's coming at you in stereo. Okay? So viewer perspective, which helps generate parallax, which helps give you a sense of depth, gives you a sense of immersion. Field of view is the other one. This one's a little bit harder to do with your neighbors around you, but you can do it later at the hotel or wherever you're staying. If you look straight forward and move your eyes out, but stay focused forward, okay, you get about there before you lose the sight of your fingers. Now, if you turn your eyes without turning your head, I can get it back there, and get it back there. So your field of view becomes almost 220 degrees or so, all right, with monoscopic view. But your main 3D vision, your main stereo is really in the center field of view. All right, so these are some of the key technologies for something VR. There are other ones that I think are also very useful, but the first three I think are actually critical to call it virtual reality. Ones that enhance it, the fact that it's interactive. You can interact with models, you can interact with the scene. It's navigable, meaning you can move. And there's two types of navigation, really, right? So if you're wearing a Vive with a lighthouse, you can physically walk around, okay? But you can only walk so far. I usually use this analogy as a magic carpet. All right, I can walk up to the edge of the magic carpet. I can walk anywhere I want on the magic carpet. That's my physical track space. If I want to go somewhere further, like the back of the room, I have to fly the magic carpet back there. Okay, it's an analogy for navigation. Collaboration or collaborative, meaning I can interact with other people, either locally or remotely. Having audio, either spatial or even just stereo audio, is helpful. It enhances the environment. Obviously, realistic rendering, if we're trying to do something realistic, could be helpful. Sometimes false coloring is more helpful, depends upon the use case. A lot of manufacturers, especially in using CAD data, they false color the parts of the equipment, whether it's an engine, a turbine. They don't want photorealistic rendering in some cases. They want false coloring because it allows them to quickly and visually identify subsets or subassemblies of a larger piece by false coloring the object. All right, so you got parts that are green and pink and blue and orange, even though in real life it's probably mostly steel. Inside the VR environment, if you false colored. True scale, and that one-to-one scale is also what helps give us that sense of immersion. It's done by correct viewer perspective. If the viewer perspective is calculated correctly by the software, objects look true scale, right? So this chair seems to be that height. If I duck down, I can look underneath the chair. I can look between the chair. All that head tracking, true scale, gives me that sense of being inside the environment. That's the academic portion. So where is the return on investment? Organizations are using this technology for a reason. You have to understand what that reason is for your organization. Buying technology for the sake of technology doesn't do anything. And I found this quote online when I did a little Google search on those topics. It says, technology provides no benefits of its own. It's the application of technology to business opportunities that produce ROI. ROI is return on investment. And anybody here that's in a business has heard ROI. If you want to implement a technology solution and you want to get justifications, be able to justify it, you probably need to find a way to calculate your ROI to invest in a solution. All right, so no, like I said, toward the end of the day, I'm going to try to keep it quick. A couple use cases within our space of clients using these technologies: design decisions in manufacturing. There's been a few, multiple great talks out there, but a few that brought up different use cases and how this technology is applied within industry. I'm not focusing on academic here, mostly on industry. That's where my expertise is. So design decisions in manufacturing, looking at parts, looking at equipment, looking for flaws early in the life cycle of a product. A lot of manufacturers usually build a physical prototype to do a final design review. Sometimes in that life cycle, they build multiple prototypes. All of that information is still created digitally first as a CAD model. When clients can look at those models digitally before building something physical, they can find design flaws earlier in the life cycle, which gets their product to market faster, which is what helps generate the ROI. Cross-functional team collaboration, we have clients that will bring in multiple teams, right? It's amazing when I go to organizations and how often the manufacturing engineers are not talking to the design engineers. Even within a big company who's producing, let's say, tractors or automobiles or planes. And there's always this contention. Bringing them together in these types of environments to collaborate allows manufacturing engineers to speak to the design CAD engineers by seeing a model that's easy to discuss and is a visual representation of the final product, and it allows them to point out problems that are going to occur during manufacturing. So the manufacturing engineers might not be a CAD expert, where they can look at the 2D drawings or just on the desktop and really understand how it's going to finally be assembled or come together. By using VR, it helps enhance communication between different design teams or different engineering teams within a company. So again, just improved workflows, ergonomics. These are all examples of clients of ours and how they do things. Again, VR is not just the headsets. They also include some of these larger scale systems. This is an example of using these technologies for what we call a hybrid environment, where you have a mixed modal use of information. This is a system where you actually have half the system displaying in VR on the right, half the system on the left showing graphs, charts, 2D data, right? And it's set up in a space that enables collaboration by bringing multiple users into the space simultaneously. In these cases, yes. So in this case here, those are really just lightweight stereo glasses. The display is not in the glasses, right? The glasses are just providing you the stereo capability by filtering out a left or a right image to the correct eye. So the glasses in this case are truly just stereo glasses. So they're much lighter than yeah, they're like wearing sunglasses. Okay. Yep. If you ever went to a 3D movie, it's very similar. So hybrid environments like this. Now again, this is not a $1,000 system, but the use case is very different than what you might get, and that's what I'm trying to bring about. Remember the title of the talk here is "One Size Doesn't Fit All." It's aligning your workflow, aligning your VR environment with your workflow. And as you're going out to uncover your workflow, you need to think about the different characteristics of what you're trying to solve, and we'll get into some of those questions, and then find the technology that best meets your workflow. Do you have another question? Oh, just stretching. Okay. All right, so virtual collaboration, that's been talked about, putting multiple people inside a VR environment. Here's ones with HMDs. This one is actually a system at Lockheed Martin where they communicate between head mounts and a more spatial system. And what they do is they have users working together collaboratively here, but then they have a cave system, which is a projection-based system over here, where a trainer or an expert is watching them do the work from an outside view and can collaborate and talk to other people. So they can all see the virtual avatars inside the cave and see what they're doing. So they're sharing this virtual environment across two very disparate types of display systems. Comparing HMDs and caves, again, cave is kind of it is a trademark name, but it's kind of become like Kleenex or Band-Aid. People use it as any kind of large immersive room display system. So this is a little bit of a comparison chart real quickly. And again, I don't mean these to be end-all be-all. These are kind of just ranges here. But resolution in a typical HMD today is going to be about a megapixel per eye, give or take, right? In a cave, it could be 2 to 16 megapixels per wall. We have cave systems that are 100 megapixel displays out there, right? So you're approaching literally the level of visual acuity that the eye can even handle as far as the number of rods and cones inside our eyes. Our eyeballs have about 100 million rods and cones, and if you have a one-to-one match of pixels to rods and cones, you're at about the level of what your eye can even potentially discern. And it's actually, in practice, less than that. Self-awareness, that's the ability to see yourself. That's an issue that some people have within HMDs, is you have to either generate your physical self or not. And without it, it's your sense of being in that environment or interacting with that environment is a little bit different when you can't see yourself. Also, if there's any kind of mismatch or lag between your virtual self and your physical self, kind of throws off your proprioceptors. And these are all things that could lead to things like simulation sickness or virtual reality sickness, whatever you want to call it. Awareness of others. Again, HMDs. Yes, with see-throughs, you can see another person, but do you see their face? Do you see their facial expressions? Can you look them in the eye? There's still some shortcomings there as far as being able to communicate and collaborate with other people when you're wearing these HMDs, as opposed to a system where you're basically wearing sunglasses. Sense of immersion, with an HMD, it's 360. Any direction you turn your head, there's going to be something there, right? That's great. Now, a physical display system, there's only something there if there's a screen there. And if you only have a screen in front of you or in front of you on the floor, well, you're limited, right? You're limited to which direction you can physically turn. If you want to look behind you, this is where you have to turn the magic carpet around, so to speak, right? You have to navigate to look something behind you if you're limited by the physical display system. User area, again, within the HMD, it's usually small. People talked this week about, sitting VR versus room VR, but even with the Lighthouse and Vive, it's roughly 15 by 15. Honestly, in a cave, that's probably about a size you'd get is maybe 15 by 15. So it depends upon the system. Collaboration, most of it is virtual within the HMD. In a cave type system, it's very easy and common to have multiple people in these systems talking together, looking at things at the same time, and really collaborating and trying to solve problems together. Comfort level, cost. And obviously cost is a big differentiator between these types of display systems. So those are kind of just I don't call it a pros and cons, just a comparison on different, different capabilities here. All right, so where do we go from here? What's the next steps? Has anyone seen the Gartner hype cycle before for technology? All right, Gartner hype cycle means technology starts and there's this period of inflated expectations, usually followed by a trough of disillusionment. All right. And then after that, things start picking up where the technology, if it's successful technology, it starts climbing the slope into, all right, second generation products, third generation products, right? It's past the early adopters. It's into the high adoption, high growth rate phase. All right, I'm going to use the term VR in the sense of VR that's been around for 20 plus years. VR, that technology, I think right now is sitting somewhere in here, climbing the slope, entering the plateau. The big question is, where does HMD VR sit in this? All right, anybody that's gone through the previous decades of VR, we're well aware of this trough and disillusionment. We remember the movie Lawnmower Man and people coming out and Jaron Lane years talking about how VR is the next coming and in the late 80s, early 90s, and there was a peak of inflated expectations. Well, what happened? Technology wasn't ready for it. The capability of stereo was there. The capability of tracking was there. The capability of viewer perspective was there. But all the technologies to do it in a way that was affordable and realistic enough. The computational power wasn't there. The graphics capabilities weren't there. And because of that, it fell right off this cliff. Now with HMD VR, and again, I'm using that specifically to try to designate between the two, one of two things are going to happen. Either there's a big slope after this big peak, or it kind of bypassed all of this and hopped right onto, dare I say, the coattails of the VR that's existed before, because there's so much infrastructure and technologies that have been in place as far as being able to deliver that. My bet is it's on here. I am not expecting a trough of disillusionment with HMD VR. I think it's finally, its heyday is finally here. It's going to be implemented and it's only going to grow. That's my bet. So what does the future hold? I predict growth, right? Growth across the board. Everybody's predicting that. There's all kinds of numbers that are floating out there, the potential size of this industry within VR, AR, mixed reality. So high adoption and acceptance rates by mass users and consumers, and that's what's really going to drive help drive the technology. I think there's going to be new collaborative and remote communication paradigms, right? So much greater adoption through tier 2 through tier 5 suppliers, access to students in high schools and primary schools. You know, thing about, I'll call it old VR or immersive VR or spatially immersive VR, it was really only by the larger companies, all right, the tier 1 suppliers, the OEMs of equipment, so the Fords, the General Motors, the John Deeres, the Boeings had been using these types of technologies for years. And then at the university level, but it was always at the university level. You know, we hadn't sold systems into high schools or primary schools that were hundreds of thousands or even $1 million. But with this type of technology, I think it's going to really lower the cost of entry. So, you know, what's going to happen? I think it's going to start eliminating constraints of 2D discussions and presentations like this. Who knows, in a few years from now, we might be doing this in HMDs, whether we're co-located or not. New forms of communication and social media. I mean, there's a reason why Facebook put $2 billion into Rift, right? Trickle-up effect. You know, I think the consumer market is going to actually end up driving greater use and greater capabilities at the professional level. And the reason I think that is the same thing happened with VR for us with caves and other systems through the gaming market. All right, when games took off, home gaming systems and PCs, that drove the ability of GPUs to do more and more realistic rendering, more polygons, more textures, more real-time shading and lighting. That's what really drove our VR market for us, and what got us away from using $1 million supercomputers to drive these things to a cluster of PCs for $50,000. All right, so if you're in IT or an engineering field, you may soon be required to acquire or support a VR system. You might need to use it as a VR as part of your workflow. You might be tasked to become an architect of a solution. I'm assuming that's 5 minutes for me? Okay, all right. Little matrix humor here about the architect. So anyway, so how do you accomplish this? Recall the title, one size doesn't fit all. So when trying to determine the best solution for your needs, what do you need to take into consideration? All right, are you going to have simultaneous users? All right, is it just going to be a one-person display or one-person environment? Is it going to be multiple people? How large of a range of motion is necessary? Are you okay with just sitting in a chair? Do they need to be able to walk around? How far do they need to walk around? If they're tethered, is tethering going to be an issue for you? How do we solve that? Okay, what else? All right, will occlusion or inclusion of the physical world enhance or detract from your experience? I think most of us were in the HoloLens talk this morning, and he talked about how, well, we got the physical world, we have the grass, we can just put in the objects around us. That's great if that meets your workflow needs. What if your workflow is for an entire plant that doesn't exist, or an entire factory that doesn't exist today? You don't have that structure around you. You need to render all of it. All right? So in that case, maybe the HoloLens isn't the best solution for you. All right? When you're playing Pokemon Go, maybe the HoloLens is the best solution for you. Okay? And I know that's an exaggeration, but my point is, think about what you're trying to solve and what you're trying to view in your environment. And I've saw it, and then do you have the physical room or space constraints? Is the system physically comfortable? If you're going to try to use these environments for a long period of time, a pair of lightweight glasses, pretty easy to wear, head-mounted display that's a few ounces, debatable. Okay, so we know they're going to get better, but again, when you're trying to solve your problems today, what are the things you need to take into consideration? And these are some of them. Several people talked about this already on the spectrum from the real to the totally virtual and where things sit. I'm not going to go into that. Does your system require a specialized computer or cluster? Right? How big of graphics are you trying to visualize? How big of a virtual environment? Do you need multiple PCs and do compositing of graphics to get the realism that you're looking for. Or if it's a multiple display environment, you probably need a cluster of PCs. All right, what's the resolution of your data with the fidelity you need to see it? Are you looking at 8 megapixel satellite imagery? If you are, your 1 megapixel HMD, you've lost an eighth of your data, or 7/8 of your data, right? You're only seeing an eighth of it. All right, so how do you solve that? By zooming into data, what needs to be visible? And then development, right? We've heard a lot about Unity, we've heard a lot about Unreal. They're both great game engines. Are those easy enough for you to develop the applications you need to do? So that's about that. I hope this was helpful or informational. If anyone wants to contact me, I'm free after this. You can grab me in the hallway or up here, but I'll open it up to questions otherwise. My contact information's up there. I got cards, etc. So.